Imagine waking up every morning in a world where fire doesn't exist. No campfires, no cooked meat, no warm shelters, no torches to scare away predators after sunset. For millions of years, this was everyday life for our ancestors. Today, many people imagine the prehistoric paleo diet as the perfect human diet. But there is one enormous problem with that idea. Before humans learned to control fire, probably somewhere between 400,000 and 1 million years ago, every single meal was eaten raw. Raw meat, raw roots, raw insects, raw fruit, everything. And yet somehow, those same ancestors evolved into a species with the largest brain ever seen among primates. How is that even possible? Modern raw food enthusiasts unintentionally reveal just how difficult this lifestyle really is. Medical studies have found that people following strict raw diets often become underweight, suffer chronic fatigue, reduced fertility, and in many women, even lose their menstrual cycles. If modern humans struggle to survive on raw food, how did our ancestors thrive on it for millions of years? To answer that question, we have to enter a world that existed long before civilization, and even before fire itself. At first glance, prehistoric Africa doesn't seem like a place rich in food. But appearances are deceiving. Most calories probably didn't come from hunting. They came from plants, not leaves, but hidden underground. Wild tubers, known to scientists as underground storage organs, or USOs, were scattered beneath the soil. These roots were packed with carbohydrates and water. Fresh wild tubers typically provided around 77 calories per 100 grams, roughly 3 times more energy than eating leaves. There was just one problem. Raw starch is incredibly difficult to digest. Without cooking, much of its energy remains locked inside microscopic crystalline structures. So eating enough calories meant chewing, and chewing, and chewing. Fortunately, humans discovered other treasures: insects, termites, ant larvae, beetle grubs. Available almost year-round, they required no fire, no weapons, and provided rich sources of protein and fat. Then there was nature's ultimate energy drink: honey. Unlike starch, honey contains simple sugars that can be absorbed almost immediately. One remarkable bird, the honey guide, actually evolved a partnership with humans. It would lead people to hidden beehives. Humans broke open the hive. The bird feasted on leftover wax. Genetic evidence suggests this extraordinary relationship may stretch back nearly 3 million years. Even today, the Hadza people of Tanzania still obtain around 15% of their calories from wild honey. Long before supermarkets, nature already had its own energy bars. Around 2.5 million years ago, everything changed. Stone tools appeared, not sophisticated weapons. Simple, sharp rocks. But these rocks transformed human evolution. Archaeologists have discovered fossil bones bearing unmistakable cut marks made by stone tools. Some evidence may even date back 3.4 million years. Our ancestors weren't necessarily expert hunters. Many were scavengers. And scavengers knew exactly where the greatest prize was hidden: inside the bones, marrow, and inside the skull, the brain. These tissues are among the richest natural sources of fat and calories. And unlike muscle meat, they are surprisingly soft. The real challenge wasn't fat, it was muscle. Human teeth are actually terrible at tearing raw meat. Chimpanzees often spend between 4 and 11 hours chewing a single 4-kilogram carcass. Imagine eating dinner for half a day. Clearly, our ancestors needed another solution. The answer wasn't fire, it was engineering. Long before cooking, humans invented food processing. Researchers Daniel Lieberman and Catherine Zink at Harvard tested exactly how stone tools affected chewing. The results were astonishing. Simply slicing raw meat with sharp stone flakes reduced chewing force by nearly 13%. Overall, chewing effort dropped by almost 1/3. Even more surprisingly, the size of food particles entering the stomach became 40% smaller. That meant digestion became dramatically easier. The same principle applied to wild roots. Pounding them with stones weakened plant cells, making chewing significantly easier. Together, these simple techniques reduced total chewing by about 17%. That's roughly 2.5 million fewer chewing cycles every year. Over evolutionary time, that mattered enormously. As chewing became easier, human jaws shrank. Molars became smaller, faces flattened, and space opened for something much more important: a larger brain. Brains are incredibly expensive. Although your brain weighs only about 2% of your body, it consumes roughly 20% of your resting energy. Scientists call this one of evolution's greatest trade-offs. Known as the expensive tissue hypothesis, it proposes that humans didn't evolve larger brains by producing more energy. Instead, they redirected energy. Compared with other primates, the human digestive system is surprisingly small. Our large intestine is only about 60% the expected size. A smaller gut saves enormous amounts of metabolic energy. But such a digestive system only works if food is already relatively easy to digest. Stone-cut meat, bone marrow, brain tissue, pounded roots. Together, they made that evolutionary bargain possible. Without cooking, our ancestors had already begun redesigning the human body. There was never one universal prehistoric diet. Some Arctic hunter-gatherers obtained almost all of their calories from animals. Others living in Africa relied far more heavily on plants. Humans evolved not because of one perfect menu, but because we became incredibly adaptable. The greatest difference between us and our ancestors isn't that we eat meat or plants, it's that our food has changed. Modern fruits contain far less fiber than their wild ancestors. Farm-raised meat contains far more saturated fat than wild game. And ultra-processed foods exploit ancient instincts that evolved during times of scarcity. Your brain is still running software written millions of years ago. It still craves sugar, salt, fat. Because for most of human history, those things meant survival. Today, they're available everywhere. The greatest danger is no longer finding enough calories. It's surviving an environment with far too many. And perhaps that's the greatest evolutionary challenge humanity has ever faced.